Hi guys, welcome to today's lecture. Today we will see a couple of extensions to our simple linear regression model that we have covered in the past lectures. If we recall, in the XLR, we have, of course, one dependent variable and only one independent variable. The first extension that we want to apply here is to add more independent variables. Let's start adding one more independent variable. For instance, if we want to see how much variation in expenses being explained by salary and family size together, or how much is the effect of salary on expenses fixing the family size, or how much is the effect of family size on expenses fixing the salary, we use an extended version of simple linear regression in the following form. In such cases, we have three variables involved. This is expenses, we have salary as one of the independent variables, and we have family size as another. Equation 1 here, it's called multiple regression model. Of course, we can add more variables to this but inclusion of more variables or extra variables in the regression model should be based on theory or hypothesis. There are two main reasons for including extra variables in the regression model. First, from economic point of view and from the policy point of view, we want to check how much is the effect of particular independent variable on the dependent variable, keeping all other independent variables fixed. From data mining point of view, we want to increase the explanatory power of the model measured by adjusted R-squares. As we add more relevant independent variables to our linear regression model, the adjusted R-square is increasing. Let me consider first expenses and salary and run the linear regression model. We did it last time. If you check the summary of the L0 model, I just call it L0, the linear model of expenses and salary. The summary of the L0 shows that 91% of variation in expenses being explained by the salary, and the effect of salary, which is 0.75, is significant p-value. Now let me add the family size to this, and we call this model L1. L1 is LM, the expenses, the dependent variable, salary, the first independent variable, plus the family size, the second variable. The adjusted R-square, or the amount of variation being explained by both of these variables, salary and family size, is about 92.2%. There's a little bit of increase, not that much. In addition to that, we see that the coefficient of the family size is not. The coefficient of the salary is still positive and significant. The interpretation of this coefficient of salary, thus term, is a little bit different. We say that the effect of the salary on expenses keeping the family size fixed, 0.76. From data mining point of view, let me again consider the L0 model, simple linear regression model of expenses and salary. So that's here, and let me add working hours to this new model L2, regression model of expenses on salary, and I add working hours here. Let's see how much inclusion of working hours would increase the explanatory power of the model. Let's please that. And let me check first the coefficients. Salary continues to have positive impact on the expenses, statistically significant, because working hours has also positive impact on the expenses, and it's also statistically significant because the p-value is 0. And the explanatory power of the model measured by the adjusted R-square is 93.3%, which is a little bit about 2% increase over the original. The next extension which we want to see is the limited dependent variable. Now, if you recall from simple linear regression model, multiple regression model, we have our dependent variable, which is a quantitative variable. Now, what if our dependent variable on the left-hand side is a qualitative variable? We want to see the effect of salary on the shift of employee. In such cases, we can see that the dependent variable is shift of employee, which is either morning shift or afternoon shift, is a categorical or qualitative variable. And the salary is a quantitative variable on the right-hand side. We want to see the effect of a quantitative variable on a qualitative variable. In such cases, we use limited dependent variable models. In our course here, we limit ourselves to the case of qualitative variables with two categories. These qualitative variables with two categories are called dummy variables or binary variables, coded with 0 and 1. Binary logistic regression model in the following form: z is equal to alpha plus beta x plus u. Z is the limited dependent variable, in our case a binary qualitative variable, coded as 0 and 1. Alpha is the constant, beta is the coefficient, x is our independent variable, and u is the residual. For example, I want to see the effect of salary on shift of the employees. Let me see how many categories we have. To make sure that this is a qualitative variable with the two categories, we see that the afternoon shift we have 12 people, on the morning shift we have 18 people, and the R function for limited dependent variable regressions, in particular for our binary logistic regression, is GLM, the shift, because this is our dependent variable, which is the shift of the employees, tilde salary, which is the independent variable. And importantly, we have to add the family binomial here, because this is a binary variable. This our dependent variable is a binary variable. Let's run this. Important for us in this at this point of time is the estimate of the coefficient of the salary in its p. Here we only check the sign, positive or negative, and the p-value. If p-value was significant, then we go ahead and check the sign. The sign is positive. That means the effect of salary on the shift of the employees, it's positive, meaning that as salary increases, the chances that the employees would work in the morning shift increases.